Hello everyone, hello scientific committee members. I'm Bayu Arif Hidayat from Universitas Indonesia. Today I will present to you my study about the effect of moment distribution and building performance. Here is the outline for today's presentation. Let's start with background information. As a country located in high seismic zone, the majority of the building here is seismic resistant building. The general combination of gravity and seismic load usually results in an uneven distribution of river numbers along the beam length. It leads us to potential problems such as crack at mid-region and congestion at support region of the beam. One of the solutions that we can offer as a design engineer is doing moment redistribution. ACI 318 allows the moment redistribution with a maximum value of 20%. The goal of the study is to investigate the changes of the structural strength and component performance of the building due to redistribution using nonlinear time history analysis. This is the research method. 7-story residential building is designed with model response spectrum analysis in accordance with ACE 716 and then will be evaluated with nonlinear time history analysis. The gravity load based on Indonesian standard or minimum design load. Seismic load parameters on the building is taken from Indonesian seismic map 2019. Seismic resistance system used in this building is dual system, consists of special shear wall system and special moment frame in Y direction. Meanwhile, in X direction, only single system special moment frame. Here is the building information, the plan view of the building, the structural element size, the structural material strength, and then the variation in this study. 20% distribution change and the location is varies. The linear modeling, we use steps, building model as fixed base at ground floor, girder and column is modeled as firm element, so wall is modeled as shell element, and slab is modeled as one-way membrane elements. Building diaphragm is assumed to be semi-rigid. The stiffness modifier to consider projection is used. Damping ratio is 5%. Model response spectrum analysis is using design-based earthquake. Building and component design criteria is based on ACE 716. Nonlinear modeling is developed using Perform 3D. 11 pairs of square ground motion is performed in accordance with ACE 4117. Sets of ground motion is matched using spectrum matching by the help of seismometry software. Response spectrum target is uniform Hadid spectra with 5% damp MCR that developed in accordance with Indonesian standard. Girder and column is modeled as frame element with concentrated hinge. Deformation control action is modeled with expected material, and force control action is modeled with lower bound material. Shear wall is modeled as fiber element that consists of force deformation relationship for three materials, that is confined concrete, unconfined concrete, and steel reinforcement. Other models are able to complete the nonlinear time history analysis, except for pairs of ground motion 4 and 10 due to one girder reach zero point. Here is the story drift diagram. The effect of moment redistribution on story drift of the building is best represented as story drift x direction. This represents the stiffness reduction on the building at x direction due to the reduction in flexural stiffness of the beam affected by moment reduction. Then the story shear, we use the story shear in the study to compare the structural strength of each model. Here is the diagram of story shear for each model. From graphic here, we can see that there is a small amount reduction of base shear x direction on M20A, M20B, and M20C model compared to M0 model. This represents the strength reduction influenced by moment redistribution on beam for each model. However, this story shear reduction is not critical. Next is component action. Only component element performance is summarized. We can see from the Graphic here that worst performance among these four models is M20C, where model distribution increases the most number of beam from O to IO level to IO to LS level. And while there is no column element and shear elements that increase in performance level. Next, girder and column local action. Beam and column with critical condition represented by the highest DCR of each rotation compared to each rotation at CV level. We can see that there's only a slight changes. There are only slight changes in the critical beam demand capacity ratio and critical column demand capacity ratio. We can conclude that the moment redistribution effect on local element is very slight that it can be ignored for this building model. The conclusion is moment redistribution affected the stiffness and strength of the building. Slight reduction is observed in the increase of storage ratio. Slight strength reduction is observed in the decrease of shear story of the building. Even though there are slight stiffness and strength reduction, the building still results in acceptable response. Component performance summary for girder, column, and shear wall shown that at this study, moment distribution affect only girder performance. Model that results in the worst component performance level is M20C, where moment distribution is down to interior girder. Local component observation on critical girder and column shown that no significant increase in element performance level. That's my presentation today. Thank you very much.